Okay, so starting from the beginning, as you told me, you always have a 90-degree triangle for trigonometry and for Pythagoras. So if you don't have this 90-degree symbol, these, for now, for year 10, you won't actually be able to solve them. You will possibly learn something else in year 12 that deals with problems without 90-degree triangles, but for now, make sure you've got a 90-degree triangle. If I was to make up a problem, say theta equal to 30, and asked you what this side was, then you would label the triangle O and A. You would identify which of your functions deals with O and A, and O and A start with the tangent function. And as you correctly said, if you're looking, for the A, you cross out the A, and you're left with O divided by the tangent of 30. Okay. The adjacent is equal to the opposite divided by the tangent of 30. Opposite in this case is 3, and the adjacent, divided by the tan of 30. And then into your calculator goes 3 divided by tan 30. .1, and then you ask yourself, does 5.1 sit well in this type of triangle? You've got a small angle. This side is probably going to be, it will be longer than, if it's less than 45, as we discussed. If it's 45, then this side is 3 and this side is 3. But because it's less than 45, you would expect that side to be longer, which it is. Just another little hint is, if you got a very unusual number on the calculator, and you're like, oh, I don't know what went wrong. In the top of the calculator, there's a little D. It looks like this. It's a D. If the calculator is set in what's called radians, which is a little r, on the very top of the calculator, then your calculator won't do this correctly. So if by some random chance your calculator gets set in radians, you need to go to the mode, shift setup. Every calculator is a little bit different. Shift setup, and it says RAD, which is button number 4, that's radians, and button number 3 is degrees. So I just pushed button number 3 to make it so that little D is there. If I'd gone 4, see how it's changed to an R, that'll stuff everything up and it'll do hidden. And occasionally it happens, you can push funny buttons and people get frustrated, so just be aware of that. Okay, next problem, if I was to, I'll do a problem where you're given the hypotenuse. So you're given the hypotenuse, let's just call it 12, and you're asked for the A. Actually, I'm going to say ask for the O. That would mean that angle was given, 42. I told you that's the hypotenuse because it's opposite the 90-degree sign, and up in the corner of your test paper you would have already written so katoa, and then possibly below that you would have done the 3 triangles and substituted in the SOHCAHTOA. You would have realised that this is a O, this is an H, so you're dealing with O sign. You would say, well, you would cover up the one you're looking for, which is O. I just cover it up with my finger, but as you said, cross it out, that's fine. And sine, or O rather, is equal to sine times the angle, which is 42, multiplied by 12. On the calculator, sine 42 times 12, 8.02, and then always ask yourself, does that sound right? Does it sound right? I've actually rounded that to 2dp by 3. Don't forget to write units. Does 8.03 sound right? Yep. Okay, while I'm here I'm going to find the adjacent, so that's just meaning I'm going to use A and H. Yep. Cosine of the angle, 42, is equal to 12 over A. A over 12. Sorry, I'll do it the way you do it. Cover up the one I'm looking for, which is A, right? So you multiply H by the cosine of the angle, so it's 12 times cosine of 42 will give you the A. Cosine 42, close bracket, 8.91, 8.92. Units are now centimetres because I told you the hypotenuse was in centimetres. Does that sound right? Notice that 8.92 and 8.03 are similar. Why might that be?
Because it's nearly 45.
Nearly 45, spot on. Okay, I think you could go all day now and do different triangles, label them, identify which triangle you need to use, either figure out whether it's division or whether it's multiplication, and solve and make sure you write the units and make sure you think, is that right? Those are the two important things, units and does that make sense, because too often people write an answer down and then move on. And the last thing I'll just put in this recording is how to calculate the angle given the sides. Okay, so the angle this time is unknown. The hypotenuse is 50. Hypotenuse is always opposite the 90 degree sign, and the what do you want to do, adjacent or opposite? Doesn't really matter. Let's make the opposite 30. O, H. Okay, so then you would have at the top of your page your 3 triangles. You would remember O and H deals with sine. O, H. Cross out the sine. Remember, go shift on the calculator. Sine, that gives you this symbol. inverse sine, and then you would go O, which is 30, divided by 50. Answer. Shift sign the calculator, 30 divided by 50. That's kind of like 3 over 5. Can you remember what the answer might be? What did we get before? It's either that one or the other one we worked out, eh? Equals 36.9. So that's just a triangle that's still a 3, 4. This would be 40, right? It's a 3, 4, 5 triangle, but it's just a bigger one.
Mm-hmm.
So it's the same ratio. So 36.9 units. What are the units here?
Oh, degrees.
Thank you. Degrees. Okay, so I've done some sort of practical type problems, but usually the first question in a exam, and possibly your exam next week, will be what is the value of theta when the ratio of O over H is equal to 0.321. Remember, so katoa, so meaning the sine one. All they've done is they've already done the division of O divided by H. So to solve this problem, you're actually looking for theta. So what would you put on the calculator, do you think? Take a guess.
The negative sign.
The negative sin, or inverse sin. So shift, sine, and then instead of putting O divided by H for like we normally do, it's already been done for us. And we'll find out the angle. Just an interesting fact, you'll never find a sin of an angle bigger than 1. The reason for that is it's always O over H. Remember, H is the biggest. So if you take O and divide it by an H, you'll get always a number less than 1. Does that make sense? And it's the same is true for the cosine, because it's A divided by H. H is always the biggest, so you'll never get a number bigger than 1. However, sometimes you'll see the problem tan of the angle is equal to 10. And that's tan, remember, it's toa. And when you take the adjacent O toa, O over A, which is O over A, you can get numbers bigger than 1, and they can get very, very, very big, and infinitely big, because you could have a triangle that looks like this. Right? Here's, well, this one's going to be infinitely small. O over A. O's really small over a big, big number. That's a small number. But if I told you this was the angle, this would change to an O, and this would change to a A. And it's a big number over a very small number, hence tan of the angle can get very big. And here again, as you said, tan, or shift tan of 10 will give you theta. I bet you that's the first question on your test next week. And you could do that in the calculator.